Hello, everyone. Thank you so much for joining us today on the webinar. I'm excited to have Doug Marshall and Benjamin Biggs here with me today hosting the webinar. I am Amy Knock, and I will be moderating today's session. Before we begin, I just wanted to let you know a little bit more about how the webinar will run. The webinar is being recorded, and the slides and recording will be available to you within 3 business days. A short Q&A session will follow the presentation to answer any viewer submitted questions that you may have. During the webinar, you can submit questions using the webinar sidebar menu. Select the Questions tab, type in your question, then hit the Enter key on your keyboard. And remember, you can ask questions anytime throughout the webinar. That concludes my brief introduction today. Doug, I will now pass the webinar off to you. You may begin your presentation.
Thank you very much, Amy. It's really a pleasure to be here with everyone. I hope you all are having a fine morning or fine afternoon, wherever your time zone exists. Benjamin and I are very excited to be able to talk to you about a new USDA standard, and it's related to the National Bioengineered Food Disclosure Standard. So we're going to start off by talking about when this rule came into effect and what it means for you. It became effective January 1, 2022, and it applies to any product regulated as a food under the Food, Drug, and Cosmetic Act. So this includes both the USDA regulated foods and FDA regulated foods. And so if you need to label your food with under the Federal Meat Inspection Act or the Egg Inspection Act, this rule may apply to you. But you also need to know that under the meat and poultry and egg, it's subject to this labeling requirement only if the predominant ingredient is subject to labeling. And the other attribute that's important is if the predominant ingredient is broth, stock, water, or a similar solution, but the second most common ingredient is subject to labeling, then it also applies to you. So who is responsible for meeting the intent of this rule? It applies to food manufacturers, it applies to food importers, retailers who label foods for retail and bulk food sales. So it requires to have information related to whether the food is bioengineered or contains bioengineered ingredients. And it applies to any food whose single ingredient contains a bioengineered substance, regardless of whether that substance is inadvertent or unintentional. And it applies to foods that any amount of bioengineered substance that is not intentional. If not a BE food, then you need to have records proving this fact, and those records need to be kept for 2 years. So what is a bioengineered food? It's a food that contains genetic material that has been introduced into a food through recombinant deoxyribonucleic acid techniques, and for which that modification could not otherwise be obtained through conventional breeding or things found in nature. So the food must contain the genetic material that has been modified by bioengineering. If that genetic material has been removed during processing of an ingredient that is derived from a bioengineered food, then that would not be a BE material. So that would be an exempt material. Again, even if it originated from a bioengineered crop, if you remove the genetic material, then that ingredient would not have to be labeled as a BE ingredient. So what is not a bioengineered food? So incidental additives, those that would not be listed as an ingredient, or as I just described, ingredients or products with no detectable BE material. And so the question then becomes, how do you know if this BE genetic material is not detectable? Well, you need records that show that that ingredient was made from a non-BE food. You can have records showing that the ingredient was refined using a validated process that removes BE material. And you can have test records that show that BE material is not detectable in that ingredient or in that food. So what are some examples of incidental additives? These would be material found in foods that you weren't necessarily adding as part of the ingredient list. So these could be substances that had no technical or functional purpose. So you could have perhaps release agents. You could have just incidental contaminants either from the field or from processing or for other ingredients. These can be processing aids whose purpose diminishes after use. And you could have substances that migrate to food from equipment or packaging that aren't technically food additives as defined. So processing aids are substances that are added to foods during manufacturing, but are removed in some manner before that final product is packaged in its finished form. And these are substances that are added to food that can be converted then into constituents normally present in the food and do not significantly increase the amount of those materials normally found in the food. These can also be substances that are added to food for their technical or functional effect in processing, but are present at insignificant levels in the finished product, and they don't have any technical or functional effect on the food after their use. We know that many ingredients are manufactured using genetically modified microorganisms to produce the ingredient. And some examples would be many of the vitamins are manufactured by microbes and then purified and used as food ingredients. We also know that many of the enzymes that are used for technical purposes during food manufacturing also have an origin from a genetically modified microbe, that genetic modification has been done to significantly increase the production of these enzymes during fermentation of that microbe. So generally, these ingredients may require disclosure. However, they could be exempt if they are incidental additives, and they would be exempt if there's no genetic material detectable in that ingredient. So for example, if you use bacillus to manufacture alpha amylase and you want to use this enzyme to break down starch into sugar, then if you use a purified enzyme where you do not have any of the original genetic material present, then you would not have to label this enzyme as a GE material. Some additional exemptions. Food or ingredients that are derived from an animal that has been fed bioengineered feed. And what the rationale for this is the genetic material from that feed would not carry over into the edible tissue. That could be muscle for meat, or it could be an excretory product like milk. Then that genetic material from that corn, for example, or the soybean would not find its way into that consumable portion of the animal. Therefore, it's not bioengineered. Products whose first ingredient is meat, poultry, or eggs, because again, the assumption is those animals and those products do not originate from a bioengineered animal. Products whose first ingredient is water or broth, whereas the second most abundant ingredient is meat, poultry, and eggs. Those two would be exempt. Pet food and animal food are not part of the rule, so they don't count. Distilled spirits, wines, malt beverages also are excluded, with the exception of low alcohol wines, those with less than 7%, and beers brewed without malt hops also could be included in the BE rule. So you need to make sure that if you're making these kinds of products that you figure out whether your product is exempt or not. Multi-component foods, however, must be labeled if the predominant ingredient is from a bioengineered source and the genetic material is still detectable. Okay, so let's talk about threshold allowance. And this occurs when any food or ingredient has been inadvertently or technically unavoidable presence of bioengineered substances up to a threshold amount of 5% for each ingredient. These could be considered exempt. Any food or ingredient that has inadvertent or technically unavoidable presence of bioengineered foods that are greater than 5% for each ingredient, those foods must be disclosed and labeled as bioengineered. And there is no such allowance for any bioengineered genetic material presence that is intentional. So if it's intentionally added and it is in excess of the threshold, it needs to be declared. And the rationale for having a threshold is we know that in agriculture, farmers are cropping sometimes BE crops next door to non-BE crops. And so you run the likelihood of using shared harvesting equipment, and you could get some residue from a BE crop that could come into contact with the non-BE crop and deliver trace amounts of BE material. And so this just allows for agriculture to continue doing what they're doing without having a lot of headaches related to incidental contamination of BE material in non-BE crops. Okay, so let's be honest, this rule can be tricky. And I want to give you a confusing example. So let's talk about products whose first ingredient is water broth or water or broth, and the second ingredient is meat, poultry, or eggs. So in this case, let's think about chicken soup, where the ingredients could be chicken soup with broth, chicken. So chicken is the second ingredient. And the third ingredient could be BE corn. Well, this particular product would be exempt because the second ingredient is poultry. Okay. Now let's take another example. So here are products whose first ingredient is water or broth. The second ingredient is not meat, poultry, or eggs. So in this case, you could have chicken soup with broth, BE corn, and chicken. Well, because the second ingredient is BE, then this chicken soup would not be exempt, and you would have to declare that it contains BE materials on the label. So again, there may be some product development activity to get you out of mandatory BE labeling requirements. Okay, there are some exceptions. So we talked about some exemptions. Let's talk about exceptions. Foods that are served in a restaurant or similar food service establishment are exempt. Again, this is package labeling. Very small food manufacturers with receipts less than 2.5 million are exempt. Foods that are certified under the USDA organic program, they do not have to be labeled as BE. Food in which no ingredient intentionally contains a bioengineered substance with an allowance for inadvertent or technically avoidable presence of up to 5% for each ingredient. So if you have less than 5% BE in that ingredient mix, then you are not required to label. So how do you know whether a food or ingredient has been bioengineered? Well, the good thing is there's a list, and the USDA ARS website is the keeper of this list. And it is expected that as more BE crops become available, that this list will likely be updated. But at least for now, this is the list. So we've got BE alfalfa, apples, canola, corn. Canola is another thing for rapeseed. Cotton, eggplant, papaya, pineapple, potato, salmon, soybean, squash, and sugar beets. So, and there are some varieties that are specified in that. There may also be non-BE foods and varieties on this list. So it's important for you to know which of these are you using that come from BE corn, for example, versus non-BE corn. Okay, so how do you know whether or not you've got, let's say, canola oil or corn oil that comes from a BE plant? How do you know whether that genetic material has been removed during refining process? Well, the removal process of that BE material must be a validated process. So the manufacturer of those oils need to use a validated process that proves that that genetic material during the refining of that oil is eliminated. And the way you do that is you can test for the presence of that genetic information. And if it's not there, then you've got verification that it has been removed. You can do additional laboratory testing to verify GE material, but it's not necessary if you are sourcing ingredients that have been processed using a validated process. So you need to get this information from your supplier where they are giving you some information that they're using a validated process for the ingredients that you're purchasing. So again, you have to have evidence that BE material has been removed using a validated process, and you need to have some testing record that verifies that that BE material has been adequately eliminated. So how do you achieve label compliance? Well, first off, bioengineered food needs to be written directly on the package, and it must be large enough and prominently displayed to be able to be read and understood by a consumer. So one way you can be compliant is you could use a USDA approved symbol. I'll show you that in just a second. You can also apply a digital link such as a QR code with clear instructions such as scan here for more information or visit this website for more food information. You can include text language that says text, a command word or a phone number for bioengineered food information. You can include a telephone number, or you can include a web hot link. This is what the two symbols look like that are the two approved symbols. So those can be prominently displayed on the package as well. So I think most people are likely going to migrate to a digital QR code because it allows you to provide much more information on the product and how you manage bioengineered ingredients in your products and in your facilities. So it's just a way to give consumers more confidence that you are taking BE seriously. Now then, if you fail to properly disclose, in other words, your products have BE material in it, and you haven't disclosed that on the label, what are the potential penalties? Well, the law as written has given USDA no ability to enforce, which is kind of curious. So they can't force a recall, they cannot seize products, and they cannot fine you. What they hope this will do is they can publicly disclose that you are not compliant with the rule, and the result of that disclosure can lead to lawsuits from consumers or competitors who are taking legal action against you for being not compliant. So they want the marketplace to figure this out and to be the police rather than USDA. So again, if you choose to want to put your brand at risk, be my guest and not be compliant with the labeling requirement. There will be gotcha campaigns from headhunters that are looking to make a quick buck off of you. So just keep that risk in mind that if you are not compliant, someone may discover that and prosecute you all throughout the press. So that's not great for your brand reputation. So how do you prove you're compliant? Well, you can have records that demonstrate what you're doing. These records include the supply chain records from your suppliers, where they declare whether they've got BE material in the ingredients that you're purchasing from them. You can you can do your own lab testing verification for genetic material to be able to give you some evidence that you're being a serious manufacturer. And if you are using a process to eliminate genetic material, you definitely need to have that process validated. So what are the issues with becoming compliant? Well, there's supply chain challenges. So when you're out there sourcing ingredients and materials, not everybody's up to speed with their declaration obligations. And because of that, they may be unwilling to provide you with any information on whether or not their raw materials and ingredients are BE or not. There is some potential for confusion because some FDA regulated manufacturers may not know that they also are required to be compliant with this rule. I believe there's probably many suppliers who have not yet validated their BE genetic removal process. And because USDA can't do any enforcement activities related to the rule, there's probably a lack of incentive to become compliant. And then from a testing perspective, it's also challenging to prove that your ingredients have less than or equal to 5% BE genetic material. So because of these issues, I'm going to turn it over to Benjamin, who's going to walk you through some of the testing considerations that are important for you to consider if you need to validate your BE genetic material removal process, or when you are doing verification testing to be able to demonstrate the raw materials and ingredients you're using are in fact free of BE material. Benjamin, the floor is yours.
Hello, everyone. I'm Benjamin Biggs. I am the National Sales Manager at GeneScan, which is an area of excellence for the Eurofins network of labs. We're here in New Orleans, where we take care of all of North America in relation to the test for BE and GMO. Next slide. In this lab, we focus on three areas: GMO and BE testing. We also do DNA testing for meat speciation, which uses the same type of equipment. And we also are the area of excellence for allergen and gluten testing for the all of North America. Next. So when you're testing for BE material, we use PCR. Now, a lot of people know PCR through the pandemic, through the testing, but this is the most widely known, and this is where we can actually look at DNA. It's also known, for example, it's also detection how we know if something's been modified. This involves all the different events, and an event is the different variations of each of the BE material. And there's two ways: there's quantitative and quantitative. One is the presence of something, so basically getting a yes or no if it's there. And the other one is to reveal how much, the percentage, which Doug was talking about, the 5%. This is where we can actually dial in and actually look at what the percentage of BE material that's been modified in the item that's being tested. Next. So when we validate a BE genetic material, let me tell you a little bit about the process. In order, what we do is we take a look at the thing and we actually look at the actual raw product. This confirms when we break that down, this confirms that the BE material is there. If we use positive controls, the raw material is then subject to the process and the finished goods, and we test to make sure it's been removed. So basically what we're looking at here is you start off with, let's say if you have corn and it's gonna be processed down to an oil, that process of DNA removal, you actually test before, you test after to make sure that DNA material is removed, and that's kind of how they validate to make sure that if something is not BE, when you go from start to finish. Next. So why is there routine verification testing needed? Well, think about it. You're looking at high ingredients that derive from BE lists. Let's say, for example, if you're using, the pineapple, the apple, the corn, the soy, and that's part of what you do. You want to validate that. You believe also reasonably that the likelihood that the supply chain could be cross-contaminated. Doug was mentioning earlier, you've got a farmer has seeds, they're doing BE corn and non-BE corn. You want to make sure that in fact you're getting the BE corn. You also want to keep your supply chain honest. Let's just say you're getting the material from your supply chain. At the end, you're ultimately responsible for that. So you want to make sure that what you've paid for, you're getting. And really, when you think about it, you want to maintain the integrity of your label. That is, when you get down to it, your label and your brands is the most important thing. And you want to make sure that when it hits the public market, that the integrity is there. And you also don't want to get any, as Doug said, some gotcha campaigns. The liability and of protecting that brand is very important, which is why you're looking to put the proper labeling out there. And keep in mind, this is something that we see a lot when it comes to recalls, competitor advantages. You want to make sure you don't give anyone the opportunity to hurt your brand or to litigate against it. Next. So what is the challenges providing that less than 5%? Well, you must know the BE material if anything, it's on your list. So you look at your list, which we're going to show you again, which Doug provided earlier, which if any of those items are on the list, there's a chance that you could have BE material. And also you got to remember that the supply chain, you want to make sure that the integrity is there. You also must know the suppliers that are removing BE, their process, it's properly validated. If you think about that, we were saying earlier, these are things to also protect that brand. We want to make sure that the process of removal is validated, and we also want to make sure the end product is also what it says it is. So is there help? Of course. As you see in the website, this is the USDA website, and if you go to the next slide, this is what you're going to see when you go there. This gives you the absolute yes or no answers as you take a look at each of your product or what you're trying to achieve if you need a disclosure. So this is what you'll see when you go to the website. Next. But let's take an example. We're going to take potato salad as an example. We're going to use that and kind of take you through the process of the USDA website to see, in fact, if you need a test or not. Next. So we start off here. As you can see in the top left, you're going to go to the disclosure determination tool. I'll tell you right, one of the things I have to say, USDA is taking a lot of guessing out of this. So you start there, it's going to bring up what you see. Is this a bioengineered food? Next. Now, let's break down potato salad. Number one, we know there's egg, we know there's potato, we know there's mayonnaise, and we know there's lemon juice. Well, we know potatoes on the list. That's a check. Egg, as you heard earlier, as Doug says, egg is not on the list. Mayonnaise, well, what is mayonnaise? As you can see, as you break these down, you have to get it down to the raw materials. Well, mayonnaise, you got oil. What's the variation? Is there canola? There's some possibilities in there. You got egg yolk. As again, egg, it's a no-go. Vinegar, Well, there you go. What is the variation? That's a question mark you have to ask. What type of vinegar? And of course, lemon juice is not. So as we look at that, we know we've got a potato as a yes, and we're going to go ahead and say, okay, this is for human consumption. Boom, we hit yes. Next. All right, the next question here on the list would be yes, the food is intended for human. Will the ingredients be used as a first or the most predominant? As Doug was saying earlier, we look at that second ingredient. Is the first one the predominant or the second? Here you go. You're going to answer yes. Next. Then is the ingredient meat, poultry, egg? As we said earlier, egg is not. We know that, of course, it takes you through this to make sure. And of course, we're going to select no. Next, it's going to be, is the ingredient from the list that you saw earlier from the bioengineered foods, or is produced from that list? As we break down the potato salad, we first looked at the mayonnaise. Well, we knew there was a potato. We knew that. Then we looked at mayonnaise. Well, guess what? That's derived from something that's on the list. So that would be a yes. Now, all of a sudden, as we were talking about earlier, here comes the list. Notice on this tool and the same website, you can go to that list of bioengineered foods. Obviously, the potato is there. Just we want to kind of let you can always refer back to that. Next. Now, does the ingredient contain detectable modified genetic material? Now, as a potato, you would say yes. It contain detectable. Now, keep in mind, that means that you can take a potato, you can get it tested and know yes or no. Next. Now, let's talk about these items. As you saw on the list before, here's a complete list. Now, you're probably asking the question, what is the event? Now, the event, as we said earlier, is the different variations of the material. So potato has 9 different variations. A variation or an event would be that this bioengineer does a certain thing. So for example, in corn, there's 33 events where maybe they have a event that they do not have to use pesticides. It's an event that resists pests. There's different variations. What we do is these items we can actually test for that event or detect if that event is a present of the potato. Next. So going back to the questions, is it inverted or technically unavoidable? So back to the 5%, okay? That's what we're looking for now is is it less than 5%? So let's just say we have tested it. We find that it's less than 5%. So we're going to hit yes. Then it says then yes, it falls. Okay, keep in mind that circle here. This ingredient is not bioengineered food. It does not require. That basically means that you've tested it. It's less than 5%. You do not need to label, which as you saw before, 5% is the threshold. Now, what happens if it is greater than 5? We're going to go down this road. We're going to hit no. This is now if it's greater than 5%. Now, that's going to ask if the ingredient is being used as an incidental additive. Let's hit no. Well, guess what? This ingredient is a bioengineered food and requires disclosure. So once again, you're going to get to the point here where it's going to tell you, yes, you need to label. This tool takes you from the raw all the way to the yes. Next. All right, so when you really break down this tool, one of the things that you got to look at is got to be where you need to work with a lab. When we talked about the potato, we were talking about, is it 5%? Is it greater? Well, that's why you need to work with a good lab that has technical expertise that can help you navigate this path to solution. So, they have to have the knowledge of the equipment being used, proper DNA extraction, and also be able to detect that. So when you work with a great lab, I mean, this is where a lot of people tend to overlook. Remember, using a good lab will give you those technical expertise to use the proper test for complicated ingredients and products. Along with the technical, they need to provide the evidence to show that it's been properly, accurately done. For example, ISO accredited is another one. You want to make sure that their procedures are correct. Also, more testing isn't the answer. Being smart, strategic is the best approach. Also, when you think about when you deal with that lab, you want to make sure that they're giving you a situation where there's not a lot of testing, but more smart strategic testing. For example, if they know something is going to have high risk, they can know what that item is and know how to narrow in the testing to recommend that. Not a broad stroke, but more of a fine tuning. Next. So if you're looking for expertise when it comes to the lab part, definitely give us a call. We can help guide you to the right direction and also really hone in on what the proper testing is and to make sure you're not doing a lot of testing, but knowing exactly. So that's all we have. We've got some questions also.
All right. All right. Thanks so much, Doug and Benjamin, for the presentation. We have had a few questions come into the chat. And just as a reminder, you can continue to ask those questions throughout here. And if we don't have a chance to address them, we will follow up with you after the webinar. So the first question is, does this finished product contain BE material?
Ben, I'll go ahead and take that one.
Okay.
Well, the easy answer for that is go to the USDA website and follow the decision tree and determine whether or not you have predominant ingredients that could be sourced from BE crops. Second thing you could potentially do is actually test that product, but it really would help the laboratory. You saw all the events that are out there for all these BE crops. The laboratory really, this is where Ben brought in, you don't need to test for everything as long as you know something about your product. And so in that case, you can limit the scope of your testing based on what you know about the ingredient list.
Great, thanks for that, Doug. Next question here, do I have to label with BE if I do not know the ingredients?
I'll take that one. That's a good one. When you look at, we deal with this a lot where maybe the person doesn't want to share or disclose the items that, so you can do a screen, but I tell people all the time is if we know that there's a high risk item and you screen it and you get a yes or no answer, that doesn't really help you. So really getting the ingredients when you're talking to the expertise at your lab is going to allow them to be able to fine tune where you need to test. So for example, if you get a yes answer, well, you're going to have to dig deeper. We're going to have to figure out exactly, if it is a yes, is it less than 5%? Well, we need to know exactly what the ingredients are to know how we fine tune to that 5%. So you can do it. And if you don't have any of the items that are on our list, you can screen it. But remember, when you do a general screen, you're going to get a yes or no answer.
Great, thank you. And then a follow-up to that that just came in, is it sufficient then to test one lot of a material to determine it is BE free, for example, to determine labeling content?
Well, it depends if you know the origin of that material from that supplier. So for example, if you know that your supplier is sourcing material from crops that are almost all BE material, then maybe you can be satisfied. If you detect BE material, then you know there's BE material there on that shipment, and you're just going to go ahead and label your product as containing BE. I think most people are probably going to try and not have to label. Mm-hmm. And if you're only relying on testing one lot of an ingredient, then that's going to open up the risk that all subsequent lots may not be BE free. So it's there is risk in any decision that you make, at least you have one data point that informs you whether or not you think that supplier is giving you BE material or BE-free material, but it may not be representative of all subsequent other lots coming from that supplier.
Great, thanks for that.
Let me add one more thing, to add a little bit what Doug says. I think one of the things is how much risk are you willing to take. So you got to think about how much liability you're willing to take on. If you're going to trust the one lot, or do you want to test to make sure? So it also depends on how much liability as a brand you're willing to take too.
Great, thank you. The next question here, I can't afford a lot of testing. What is the easiest route to take?
Yeah, well, that's a good one. I'll take that one, Doug. I think you could be very safe by just simple labeling it BE or may contain BE. Then you're covered. Now, a lot of people, as Doug said, do not want the label because it could be a deterrent when it comes to the marketplace. But if truly you want to make it easy, if you put that down, you're covered. It doesn't necessarily mean you have it in there, but you're covering the fact that we're not going through all the testing. So that's I guess the simple answer on that.
Great, thank you. And I think we have time for a couple more questions. I'm just getting caught up here in the chat. The next one, is USDA BE the same as non-GMO project?
Oh, I guess I'll get that one, Doug also. I get that question a lot. There is a state of confusion when it comes to the non-GMO project and the USDA BE. The question comes down to, are those two terms the same, which they are. The BE is is really a consumer labeling act. It's there to inform the consumers on what's going on. Where the non-GMO project, it's pretty much a voluntary, agenda-driven, I guess, in the marketplace. It's what people pay to get on their product. So they really are accomplishing two different things, but they're not one and the same. So yes, if you're looking from a marketing perspective to get the non-GMO project label, keep in mind that it's agenda-driven, that you're trying to promote non-GMO, whereas the BE is really consumer labeling. So that's the best way to put it.
Great, thank you. And I think we have, do you want to add something else, Doug?
Yeah, and an example of this might be a piece of meat. If you want to declare that as not containing genetically modified material, then you wouldn't go through that through the USDA labeling rule. You would just purchase the non-GMO label, because meats are exempt from the BE rule. So you could still declare it as not containing, but with the USDA rule, you're not declaring anything if the material doesn't have BE. So again, one is more of a marketing issue, and the other one is a regulatory compliance issue.
Great,
I'll add one more thing to that. There are also different rules for each too, and I don't go down the rabbit hole with this, but as meat does not fall under the BE regulations, the non-GMO project deals with meat, dairy differently. So keep in mind that, remember, they're trying to achieve two different goals.
Great, thank you. And I think we have time for this one last question here. So if the product is non-GMO project verified, do I need to be BE label compliant also?
Well, I guess Doug, I'll follow what I was saying. Keep in mind you're achieving two different goals here. So they're two different objectives. So, you'd have to look at it, what you're trying to achieve. So if it's non-GMO compliant, there's a good chance you don't have to label them BE, but remember there's two different goals and they're doing two different things. So I would not use the blanket statement like, if you have this, you don't have to do this. I'd say yes. That remember, you have to look at each one individually because they're just accomplishing two different objectives.
Great, thank you. It looks like we are all caught up here in case we did miss any questions. Like I mentioned earlier, we will address them with you right after the webinar. But that wraps up the Q&A session. And again, I want to remind everyone that a recording of the webinar, along with a copy of the slides, will be available within 3 business days. And thank you so much, Doug and Benjamin, for your presentation today. And thanks everyone for attending.
Bye.
Bye.